Hello, in this video we will see how we can painlessly model periodic processes, in other words, write equations of processes using sine and cosine graphs. Let's look at the example. So some quantity, changes with a cycle of 24, let's say 24 hours. It can be temperature, it can be tide, more or less, I guess, 24 hours. If instead of hours we say minutes, it could be Ferris wheel, one revolution, or something else. So let's say the minimum value of that quantity is 2 and the maximum is 20. It could be temperature from 2 to 20 degrees. It can be tide from 2 to 20 feet or meters, something like this. And let's say it starts at the lowest value. So we need to write an equation. It's really good idea to start with a graph. We know a couple things from this description alone. I guess you know what 24 is. Yes, I hope you do. But what you do with 2 and 20, it's really easy to make mistakes, and also it's not really obvious which function to choose, sine or cosine. So let's make a graph. Okay, I call the variables t for time and q for quantity. It doesn't have to be this way, it could be x and y still. So 24 hours is our cycle. You know what, I'll label it later. Let me take care of 2 and 20 first. So if 2 is the lowest and 20 is the highest, I know that my graph will oscillate between these two values, and I know that it starts at the lowest, so I can pretty much draw my curve. Lowest, highest, and so on. So now I can mark 24 because that's the length of my cycle. Okay, now the next crucial step, I need to find the midline. So halfway from 20 to 2, I need to draw a line. What's the equation of this line? So what some people do, they say, okay, 20 minus 2, 18, divided by 2 is 9. All right, so let's try 9 over here. So as soon as you decided to try, good for you. Because if not, it's wrong. Look, from 20 to 9 is 11 units. From 9 to 2, 7 units. So it's not in the middle. So that's wrong. In order to find the midpoint, point halfway from 20 to 2, we need to find the average. So 20 plus 2 over 2 is 22 over 2, 11. So let's try again. Don't trust anyone, including yourself and your teacher. Okay, so 11 from 20, it's 9 units. From 2, it's 9 units. It's right in the middle. So this is my midline. Okay. What 9 is actually is half of the height, as you see. So the entire height is 18. 9 is half of it, and that's our amplitude. So we can start writing the equation. Q of t equals, so the amplitude is 9, as we know. Now, sine or cosine. We know that sine, look, neither of these start at the origin nor at 1. I mean, after certain transformations, we ruined all of it. But, so instead of looking at the x-axis for reference, we are going to look at the midline, at the line of oscillation. Focusing on this green midline, where does the graph start? It starts at the lowest. It doesn't start at the axis level, so it's not sine. Is it cosine? Well, almost. It's upside down cosine. If it were cosine, it would start here. But it actually starts here, on the bottom. So it's cosine upside down. Okay, so keep writing. So we need to write minus 9 cosine. Oi, what's the frequency? We need to calculate it. Frequency, as you know, relates to the period in the following way. 2 pi divided by the period. Actually, we mostly use this formula so far, 2 pi divided by frequency. But if you multiply both sides by b, or if you cross multiply, you're going to have b times period equals 2 pi. So if you divide by period both sides, you get b equals 2 pi over period. So they're just inversely proportional. And it doesn't remember, you don't need to remember both formulas, you just remember to get one, you need to take 2 pi and divide by the other. So in this case, frequency equals 2 pi divided by period, which is 24. And it becomes pi over 12. We can write it as a decimal, I don't know if you need it. So you can take 314 or just pi and divide it by 12 on a calculator. It's approximately 0.26. I don't know, we'll see if you need it. So now we can plug it in the equation for b. Keep writing pi over 12 for now. Now, t minus what? Okay, this minus what thing, this c, is something we haven't discussed much. It's a phase shift. It's a horizontal shift. Although if you start with a cosine graph here on the bottom, negative cosine, we don't need to shift anything. So I really don't need this parenthesis, and I don't need a shift. So I'm just writing t. Plus d. D is my midline level, my vertical transformation, vertical shift. So this is 11. This is my equation. Not too hard if you follow the procedure. Now, suppose instead I have the following graph. So it doesn't start at the lowest level anymore. It starts somewhere else. And then it goes a little bit down. So this is my lowest. And then that's the next lowest. So the transformation that occurred to my previous graph, and everything else is the same, is shift to the right. Let's say it shifted 3 units to the right. So then instead of 24, it's actually 27. And I'm going to remove this 24 so it doesn't distract us. Okay. What happens to the graph? So that's when we need a phase shift. So my entire equation, let's call it q1t, will stay the same, except something that I need to add or subtract from t. So we are going to look at this in a moment. Plus 11. Now, the shift happened from here to the right. So because it's to the right, we need to subtract a positive number. Now, we shifted 3 units to the right. So we're subtracting t minus 3. That's it. Now, couple warnings here. If you use your calculator, by the way, do type this on the calculator to check that you got the same graph. If you want to see that the graph that you type and graph on your calculator matches your picture graph, matches your story, you also need to arrange your window in a way that you want it to be. So your x would be maybe from 0 to maybe 30, and your y will be from 0 to 20 something. You want to see the top, 20 something, maybe 22. And then your graph should match that. And if it doesn't, I want to give you a couple warnings here. So the tricky thing about this is syntax. Your calculator will open parentheses right after cosine. So make sure you close that after you typed your phase shift, before you added 11. Otherwise, your 11 will be inside of your cosine function, and it's not right. 11 is the vertical shift, which is outside of the function. Another warning. Sometimes you may see a notation of this function that looks slightly different. So look what I'm going to do. I am going to open parentheses. So instead of pi over 12, I'll write 0.26. So this is my 0.26. And what I'm going to do, I will distribute 0.26 over t minus 3. So it will be 0.26t minus 0.26 times 3 is minus 0.78, and then close parenthesis, plus 1. Of course, if you type this in your calculator, you will get exactly the same graph. The reason I'm showing to you that you may see this equation in problems, or if you do trigonometric regression, your calculator will produce this format. So you need to understand that 0.78 is not the horizontal shift. In order to see the shift explicitly, it must be a number subtracted from x, or from t in this case. And frequency will be multiplying this little binomial. So in this format, in order to see the shift, you would need to factor out 0.26. In other words, go back here. Okay, let's do a little practice here. So let's write the equation for the same graph, but now using positive cosine graph. Can we do that? Here is how we do it. So you need to find the beginning of cosine cycle. Cosine cycle, there are many cosine cycles, of course. One starts here, the other starts here. It's easier for me to find this position. What is it? This is the point halfway between 3 and 27. So that's the average. Average of 3 and 27, or midpoint, is 3 plus 27, 30 by 2 is 15, okay? So my cosine cycle starts at 15. So then I would not need to flip it over. So here's my equation, 9 positive cosine, the same frequency. I definitely want to have this format explicit for phase shift, because now I am shifting my graph 15 units to the right. And everything else is exactly the same. It's not that hard to figure out that number. 15, the cycle is 24, right? So 15 minus 24 is negative 9. So instead, I could write t plus 9, because now I'm shifting to the left. And one more little exercise. So let's now write equation of this graph using sine function. I want positive sine. Everything else will be the same. It is just the shift that I need to worry about. Okay? So here's the key. You need to find the beginning of the sine cycle. Sine starts at the origin unless it was shifted somewhere. So now the graph is shifted together with its axis of oscillation. So we need to look at the axis of oscillation and find where the cycle starts. Try to find it. Okay, if you found this point, good for you. So this is the point where the graph starts on the axis of oscillation. What is this value? It's halfway from 3 to 15, so 3 plus 15, 18, divided by 2, so it's 9. So this will be t minus 9. Again, I would like you to graph this with a calculator. Don't forget to put this parenthesis around and see if your graph matches the diagram. All these graphs, all 4 equations that you see here, they should all graph exactly the same curve. And one last quick comment. Sometimes you're asked to read minimum and or maximum value of the process from the equation. Suppose you didn't see this equation. Just looking at the graph, how can you say the highest and the lowest? Just understanding the structure of this process, the graph, helps you answer this really easily. 11 is the axis of oscillation. 9 is the amplitude. So amplitude shows how far it oscillates up from the axis of oscillation and down. So you just do 11 plus 9, 11 minus 9. And it gives you your max and min. All right, you're fully equipped now to do modeling with sine and cosine.